Welcome to our fourth and final part of describing network security technologies. Continuing with authentication, authorization, and accounting, or simply AAA. Folks, I want to promise you that I'm not being an annoying instructor and mentioning it in this manner. It is an important order because authentication is who are you, your first method of access. Give me login credentials. Authorization, only taking place after you have authenticated, is going to be more of what can you do. And give me a moment, we're going to go over some examples of what can an administrator do or what can a user do. And then accounting is going to be more of what did you do? An account of, for example, what changes did the administrator make? Or what sites, how much data did the user transfer? How long was the user connected? And then keep in mind that these services, authentication, authorization, and accounting, can all either be done local to a security appliance or in a more centralized manner using protocols such as Radius and TACACS with a centralized server, for example, Cisco's ICE. So let's go a little bit deeper here. Once again, some of the use cases. I want to go back to what we were talking about earlier about through a device or to a device, because I really do want you to understand that there are multiple different use cases for AAA. So as the slide here is showing, remote access VPN to the ASA, that is most certainly going to be an end user use going through, sending traffic through this security appliance, again, the ASA. So in this case, we would authenticate the user by a username and password. Authorization would be maybe pushing down a context-based access list. So now we can control where the user's VPN traffic is going. Or maybe, again, just keeping track of how much data they transmitted. And accounting would be, for example, how long was the VPN session open? But I want to say it again, that's going to be through the network in a user's use case. What about an administrator, an administrative access, and administrative use case? So folks, the way I remember differentiating these is administrative access is going to be to the devices, not through the devices. So once again, we would be using maybe a TACACS server instead of a Radius or LDAP server. And that TACACS, really TACACS Plus, standing for Terminal Access Control Services from the Department of Redundancy Department. But this would allow us to, of course, authenticate the administrator with the login credentials, but then assign a privilege level, maybe even going as far as assigning a list of commands that that administrator is able to enter, again, in the authorization category of AAA. And then again, accounting here would be maybe when did the administrator's login session start and stop? Maybe what actual changes were made while that administrator was logged in. So we can identify, look at the login administrator B. Smith did indeed type in a shut on this interface at 3:15 in the morning, and that's when our problem started. But please understand something. AAA, my goodness, AAA has been around, has been discussed, has been used, and has been expanded upon for many, many years. Absolutely, in my, at the time of recording, almost 29 years of experience in the industry. We simply need more. And that's where IAM, or Identity and Access Management, comes into play. Folks, as we can see over here on the right, it really does add more in the way of context. So it's not just using the authentication of AAA to identify the who are you, the authorization of AAA to identify what can you do, but also the how are you accessing? Hey, whoa, wait a minute. You're coming in from a non-corporate assigned PC. For all we know, it could be the lobby desktop of a hotel in some random part of the world. And you're trying to access this on a weekend, on a Sunday at 2 in the morning. And again, this machine that you're using is not even with our antivirus, with our personal firewall. It does not meet our posture. So then we can go through and either restrict, outright deny, or grant access. Now, the key is, though, you need some kind of a system to provide that context, the who, what, when, where, how. You get the idea. And that's again where Cisco's identity services engine comes into play. So once again, just a pretty little picture here with numbered steps, similar to what I was talking about a moment ago. So the endpoint is not only going to be authenticated, but so too is the end user. And we're able to profile how are they connecting. Posture assessment with what are they using to connect? Once again, is it going to be a non-corporate asset, a non-corporate laptop or a desktop that once again does not have our security software on it? If we need to reject the connection, we could do a COA, a change of authorization. Or we can even do a COA, which is going to be, okay, you've properly authenticated and you've met all of these requirements. So I'm going to do a COA, and now you re-access the network, but with a security policy applied in a controlled manner from a controlled endpoint. Continuing on with the security services in more of a classic offering with a VPN or a virtual private network, folks, please understand, would you believe the term VPN was never really standardized? So to a security purist like me, a VPN has to provide 4 very, very clear services. Again, your authentication, your protection, encryption, your anti-replay, and your data integrity, for example, by way of a hashing. And by the way, those are in no particular order, just mentioning the 4 services. So to me, once again, if you're like me, a security purist, this is only going to be something that's provided by an IPsec VPN, IPsec-based VPN, or an SSL, really today a TLS VPN. Understand, folks, we have not used SSL, true SSL, in many, many years. We've actually been using transport layer security, or again, TLS. So again, our VPN is providing secured, encrypted, authenticated, non-replayed, and communication services for data that is in good standing between source and destination, whether the source and destination are going to be appliance to appliance, maybe site to site, or end user to appliance. For example, my goodness, a cell phone, a tablet, a laptop, a desktop to a corporate office. And then as we finish up our communication here, I like this stuff. I like this part. Finishing the conversation the way we started. Folks, if we started with our network today is going to be physical offerings, virtualized offerings, giving logical services, then please understand the form factor of our security appliances are also going to fall into those same kinds of categories. But what I mean by kinds of categories is we have physical security appliances, let's say laying my hands on an actual physical Firepower 4000 series appliance, or a virtual firewall, maybe in the form of an ASAV, or even cloud-based security services, as is available today with, again, the enhanced suite of services offered by Cisco's umbrella. Again, keeping in mind that we can have a hybrid model, especially with enterprises today being more of a hybrid of physical and virtual, on-premise, and even cloud-based services. So a modern enterprise network today is really going to be, if I may use a fancy word, an amalgam, a combination of bringing together of multiple different components, whether those components are going to be in one switch block or another switch block offering different services, going back to the very beginning of our conversation, are going to be in a physical form factor or a virtual form factor, but on-premise, or even in a cloud-based offering off-premise. All again, not only evolving for our security needs because our attacks have evolved, but ultimately to provide defense in depth, our layers of an onion or our layers of an artichoke.